Welcome back to the programming session. Now you got the idea? That is, how to stop the computation when recurring occurs like this by using the RAT to remember remainders. One possibility is to keep x in the RAT whenever new remainder is stored in x, like here. Okay, and then, for example, use some variable, say I, as the index of the next empty box in T, and store x in T. Okay, and we should increment the value of I by 1, like this. Okay. Well, initially I should be set 0 because the RAT always starts from 0. Also, this x should be stored. T I equal x, and then again increment I. Okay, because this is also the point where the new remainder, that is 1, is stored in x. By this way, we can keep obtained remainders. Then here we check whether the current new remainder x is in the RAT or not. Okay, so like this. Remember, these two vertical lines means that a logical OR. So what we want to check here is whether the remainder x is 0 or x is already recorded in T. Well, here we have one problem. This check is possible, but it may bother you. So let's consider some other way. Instead of using the array to store remainders, why don't we use each icebox as a sign or flag whether I appears as a remainder? That is, again, each time x is stored a new remainder, we simply set 1 to tx. Okay? For example, here, store 1 to tx. Okay? Then, if tx is 1, then it means that x has appeared before as a remainder. So we set 1 to tx at here also. Okay. And then these two places. Clearly now we don't need a variable I anymore, so just erase this. Okay. Then for checking whether x has appeared as a remainder, this part, we can simply check whether tx is equal to 1. So this can be changed to this check. You see, this part becomes very simple, okay, right? So by this way, we are asking whether either x is equal to 0 or x has appeared as a remainder, that is, t of x is equal to 1. If one of them holds, then we set 1 to the variable stop to terminate the while loop. Note that the remainder of the division by d is from 0 to d minus 1. So we only have to prepare our RAT with d boxes indexed from 0 to d minus 1. Let us execute this program. But before the execution, let me change this print command so that the value of t of x is also shown on the screen. So let me change it. Okay, now save it. And execute it. For the execution, let me use the new terminal. right? So okay. So let's execute this program. .rb. And then let's use the 7. Oops, it stopped very early. Look at this output. Okay. This is the quotient and the remainder of the first division step. That is 10 divided by 7. On the other hand, this is the value of t of x, tx. That is t3. Although the remainder 3 has not appeared before, this shows that the value of t3 is already 1, and then the computation is stopped. Let's look back the program. Here, right after the new remainder is stored into x, we set 1 to tx. For example, in our execution, as soon as the remainder 3 is obtained, we set 1 to t3. So it is clear that t3 was 1. Hence, this condition holds, and the variable stop is assigned 1 here. Okay? So we made a mistake. It is too early to set 1 to tx. We should have set it 1 after checking whether tx has been already assigned 1 before. So let's change this order. Move this statement. Okay, erase this one. Move this statement after the check. T of x equals to 1. Okay. Note that we don't have to worry about this here because there is no checking. Let us execute this modified version. Save. And then Ruby. And use 7 again. You see, it stops automatically when the remainder 1 appeared again. Right? The values in the third column are values of t of x. They are all 0 here because all remainders are new. And the last one is 1 because the remainder 1 has appeared before as the first remainder. Okay? Compare our result with the previous one, this one. We could stop the computation just before the recurring starts. Let's try with another divisor. For example, 24. Again, it stops automatically here. The values of the third column are 0 until 16 appears for the second time. And the division process is terminated as soon as the same remainder 16 appears. That is, t of x is equal 1 occurs. So this is what we wanted for the answer to this problem. And with this, we conclude this exercise session.